Okay, so we are going to discuss today basic concepts of statistics. So this is about introduction to statistics. Okay, so we will just have an overview, some basic terms of statistics until levels of measurement of data. Okay, so we are going to have to define first what is data and statistics. So data is basically the building blocks of statistics. So without data, there is no statistics. So data basically is the information coming from observations, counts, measurements, or responses on surveys. Okay, so statistics is the science of collecting, organizing, analyzing, and interpreting the data that previously mentioned, which is on the observation coming from or counts, measurements, or responses. So statistics is responsible for collecting, organizing, analyzing, and interpreting that. Okay, so and in relation to statistics is there is the term population. So when we say population, that is the collection of all outcomes, responses, measurements, or counts that are of interest to the researcher. And sample is a subset of a population. It is a part of the population, but the sample must be not only a subset of a population, but it is representative of the population. Meaning to say, uh, it is, although it is a small portion of the population because it is a subset, but the characteristics of the population is also found in the sample. Okay, so let us have this an illustration of the relationship of populations and samples. Okay, so for example, there is a survey uh, done to 250 college students at CTU, and they were asked if they smoke cigarettes regularly. And 35 of those who were interviewed said yes. Now we will identify the population and the sample. Okay, so if we are going to draw the diagram, okay, so the whole rectangle is consists of all students of CTU, that is the population. And the sample is the responses of students in a survey. Okay, so in this case, you have 250 college students. Okay, so that is your population, and 35 is your sample. Or if we are going to take a look at the, let's say, 10,000 college students and 250, that is a sample because it is just part of the school. But if that is the population, CTU has 250 students only, then that makes it a population. When we say parameter that is in relation to population, that is a numerical description of the population, or that is a what you call observable characteristic of the population. You call it parameter. While when you say statistic, that is the a numerical description of a sample, or that is the observable characteristic of the sample. That's why it is statistic. Okay, so if we are going to denote that, that is parameter is to population, as statistic is to sample. So the letter P, parameter, population, the letter S, statistic, and sample. Okay, so this one. You will decide whether the numerical value describes a population parameter or a sample statistic. So for example, this one, letter A. Recent survey of a sample of 450 college students reported that the average weekly income for students is 1,200 pesos. So, because the average of 1,200 is based on the sample 450 students, college students, then the 1,200 is a sample statistic. Okay, so another example, the average weekly income for all students is 1,200. And because it is for all students, the 1,200 becomes a population parameter. Let's move on to the branches of statistics. So statistics basically it has two major branches. This is the descriptive statistics and the inferential statistics. So these are the statistics that we are going to discuss here for the entire term of our class. And you might be wondering why is there probability? So probability is the bridge between the two. So you need to understand concepts of probability so you would understand better the inferential statistics. Okay, so when we say descriptive statistics, that involves the organization, summarization, and display of data. So you are simply summarizing. So in descriptive statistics, you are simply summarizing and you are not doing any inferences. While for the inferential statistics, that involves using a sample to draw conclusions about a population. So you observe a sample and whether that sample is generalizable to the population. So for example, the clinical trial on the COVID-19 vaccines, I mean, they are only getting sample people to be tested of that vaccine, whether it is effective or not. So to test its efficacy, it is tested on a randomized control group. So the samples are randomly chosen and they are given the vaccine and they were observed. So based on what they gather until a phase 3 trial, they would say some vaccines would say that they are 92% effective, or others say it's just 50% effective. So that is the use there of the inferential statistics. You are going to observe a sample and then out of what you observe in the sample, you will generalize it to the population. Okay, so here's an example. In a recent study, volunteers who had less than 6 hours of sleep were 4 times more likely to answer incorrectly on a science test than were participants who had at least 8 hours of sleep. Decide which part is the descriptive statistic and what conclusion might be drawn using inferential statistics. Okay, so the statement 4 times more likely to answer incorrectly is a descriptive statistic because it is just telling something. It's just a point summary. While an inference drawn from the sample is that all individuals sleeping less than 6 hours are more likely to answer science questions incorrectly than those who sleep at least 8 hours. So that is the inference there. So those who were sleeping less than 6 hours, they are more likely to answer, or they were more likely to answer wrong on the science question than those who had enough sleep of at least 8 hours. Now let's move on to data classification. So there are types of data that we will encounter when we do research. Okay, again, remember that data is the building blocks of statistics. Okay, so there are two types of data that we encounter, that is qualitative data and quantitative data. So if we draw that in a diagram, you have two. When we say quality data, that consists of attributes, labels, or non-numerical entries just like gender, just like course, just like year level, level 1, level 2, like that. So those are qualitative data. Or you have religion, that's qualitative. For civil status, married, single, like that, it's qualitative. Or you would say performance of your faculty as excellent, very satisfactory, so that is qualitative. So you cannot equate that with numbers. You can only code that. So if you are a BS statistics or major, you will learn how to code qualitative data so that statistical software is going to analyze it just like quantitative one. Okay, so when we say quantitative, these are numbers. It consists of numerical measurements or counts. Okay, so uh, quantitative data, okay, if we're going to illustrate it like that, you have there the names of the students are quali, could be male or female, and the GPA, that is the quanti part. Okay, so quantitative data, I forgot to mention it here, but quantitative data is either discrete or continuous. So when we say discrete, those are results of counts. No half value, no decimal. Okay, counts man. So say for example, the number of students in my class is 20. So that is discrete. But when we say the average height of my students is 5'1", that becomes continuous. There is a decimal point, there is a decimal value, and continuous is a result of measurement, while discrete is a result of counts. Okay, so discrete answers the question how many, while continuous answers the question how much. So that is the difference between the two, discrete and continuous. Then we have the levels of measurement. There are 4 levels of measurement. That's nominal, ordinal, interval, and ratio. Nominal being the lowest, ratio being the highest. So this is very important when you are going to treat data in research, because your statistical treatment is dependent on the type of uh, measurement that you got, or the variable that you get. How did you measure your variables? Okay, so if we are going to yeah, so that's from the lowest to the highest. Okay, so the ratio is the highest. So when we say nominal, that is just simply naming. That's nominal naming. So there is no mathematical computations that can be made at this level, but you can count. You can have the frequencies, for example, males and females. So in a class of 10, there are 6 males and 4 females. So males consist of 60% of the class, while females consist of the 40% of the class. So that's nominal. You're naming and you're not doing mathematical computations for that, but you are simply summarizing them in terms of frequency counting. Examples of variables in the nominal level: colors in the Philippine flag, or name of students in your class, or the name of your classmates, or the textbooks you are using this semester. Those are nominal. When we say ordinal, it has still a characteristic of the nominal, only that this time it is arranged in order. There is ranking, but the difference between orders is not meaningful. Okay, so for example, class standing, freshman, sophomore, junior, senior. This is the year levels. We call this one the year level. So, although we know that seniors are the highest, but we cannot subtract senior minus freshman equals junior. No, it's not like that. So, it's just like that. So, the same with the nominal, you will simply count how many are freshmen, how many are sophomore, juniors, and seniors. Or the numbers at the back of the player's shirt. Don't you know that it's also ordinal, or some others classify that as nominal, the numbers at the back of the basketball player's shirt. So again, do not be confused with the nominal and ordinal, because the ordinal still has the characteristic of the nominal, only that there is some ranking involved. or let's say the first runner-up, second runner-up, the Miss Universe that is in the ordinal level, or you are first year, second year, that's the other thing for class standing, or if it's the honor roll in the class, honor roll, that's first, second, third, fourth, that's ordinal. Now let's have interval. So when you say interval, it is arranged in order. There is differences there that can be calculated, but there is no absolute zero. Like for example, temperature. Years on a timeline, Atlanta Braves, World Series victories. So, pila sila kadaog. So, there is no, what you call this, meaningful difference. Because when you say temperature, there is 100 degrees centigrade, there is 50 degrees centigrade. You can subtract. The difference is 50. But you cannot say that today is, or you cannot say that 100 is twice as hot as 50. So it's not like that. While on the highest one, the ratio level, okay, so you have two data values that can be formed. So one can be expressed as a ratio of the other, like ages. If you are 20, I am 40, so I would say, I am twice as old as you are, or the grade point average. So the other one has 1.2 GPA, the other is 2.4. So his GPA is twice as high as the other one. Or the weights. Let's say I weigh 50 kilograms and my child is 25. So I weigh twice as. Okay, so moving on. So going back to the ratio level measurement of variables. So again, that can be expressed, the other one can be expressed as the ratio of the other. Or another example aside from weights is the number of children in the family. Okay, so the other one has 2 children, the other one has 4 children. So one will say that uh, he has twice as big family as the other. Okay, so another thing that you are going to take note of variables in the ratio level is the meaningful zero. There is absolute zero. So when you say zero as the number of children, that means to say the couple was not able to bear a child. So it's zero. Or when you say income, zero is the income. So that means there is no really income. Unless nahurot na it's all been deducted out, but there is really no income. So if we are going to summarize the levels of measurement in a table, in the nominal, okay, so you categorize your data, that is check, okay, but you cannot order your data, you cannot subtract also data values, and you cannot determine if one value or one data value is a multiple of another. For the ordinal, yes, you can put data in categories and you can arrange it in order, but you cannot subtract nor you cannot find the multiple of another. So there is no ratio. Interval, yes, you can put data in categories, arrange in order, subtract data values, but no meaningful ratio. Whereas in the ratio level, all are present. You can put them in categories, you can arrange them in order, you can subtract data values, and you can find meaningful ratio. Okay, so that's all.